All right, so this video is going to work on applications of system of equations, or excuse me, systems of inequalities. So this is a whole bunch of word problems. So what I'm going to do is I'm going to read through this first one and I'm going to decide what x and y are going to represent, just like we did when we were solving systems of equations. So what I don't know is how many pounds of flour and cornmeal I'm going to buy. So I'm going to say that X is going to be my pounds of flour, because that's the first one that they wrote. And then I'm going to have Y be the pounds of cornmeal. So then I'm going to make an inequality that represents the cost, and I'm going to make a separate inequality that represents my total pounds. Okay, so let's start with the money equation. So I have 150 for flour per pound, so 150x plus 250y, and I want that to be less than, not less than or equal to, just less than $25. And I want at least 6 pounds of flour. So I'm going to say, 6 pounds altogether, not 6 pounds of flour. And at least means the minimum I want is 6. So now I'm going to actually make my graph of my inequalities. So this is going to be my pounds of flour. And this side is going to be my pounds of cornmeal. And what I'm going to do first is I'm going to do this second equation. So if I'm looking for x and y intercepts, I'm going to take out y. So my x-intercept is going to be 6. 1, 2, 3, 4, 5, 6. And my y-intercept is also going to be 6. And I'm going to connect those. Can't see what I'm doing. My hands are in the way. Now, one thing to be aware of here is, since I am dealing with a real world scenario now, you'll notice I'm only graphing in quadrant 1. It does not make sense for us to have negative pounds of flour or negative pounds of cornmeal. We're only dealing with positive numbers. So, pardon me. With this equation here, I'm going to go ahead and manipulate this equation into slope-intercept form, because I can't graph this the way it is. I'm not going to get pretty intercepts for both x and y. So first I'm going to have 2.5y is less than negative 1.5x plus 25. And then I'm going to divide everything by, I'm dividing everything by 2.5. So negative 1.5 divided by 2.5. I have to simplify this. So what I would do first is I'm going to multiply this by 10. It's not going to change my fraction, but I'm going to get rid of the decimal. So I have negative 15 over 25. Well, 15 and 25 are both divisible by 5. So dividing this by 5 is going to leave me with 3. Dividing that by 5 is going to leave me with 5. So my slope is negative 3/5 x. And then 25 divided by 2.5 is going to be 10. So I'm going to go up to my y-intercept of 10. And I'm going to go down 3 and over 1, 2, 3, 4, 5. That's my first. 2, 3, 1, 2, 3, 4, 5. Just barely enough space on the graph. All right, and now this is going to be a dashed line because I am just going to be less than 25, not equal to 25. And I'm not putting arrows on the end. So I need to be greater than my pound line and less than my money line. So that's going to be this space in between here. Now, when I go to list 2 possible solutions, there's a slew of different answers we could have because it's all of these coordinate points in between. So I'm just going to pick 2, and I'm just going to say those are my solutions. So I'm going to pick this one right here, and I'm going to pick that one right there, just because. So this would be 1, 2, 3 pounds of flour, and 1, 2, 3, 4, 5 pounds of cornmeal. And I'm just going to abbreviate cornmeal as CM. And this would be 6, 7, 1, 2, 3. So this would be 7 pounds of flour, 3 pounds of cornmeal. All right, here we go on to the next one. We're purchasing perch and salmon, which are both 2 types of fish. He wants to buy at least 50 pounds of fish, but cannot spend more than $240. So I'm going to label X as perch and Y as salmon. And again, I'm dealing with pounds. So I'm going to do a pound equation and a dollar equation. So I know that the pounds of perch plus the pounds of salmon need to be at least 50 pounds, which means 50 is my minimum. And then perch is $4 a pound. Salmon is $3 a pound. And we cannot spend more than $240. We could spend up to $240, but we can't go over that. So I'm going to start, let's see. 14, 15. I only have 15. So this is pounds of perch. And this is pounds of salmon. So I'm going to say that my scale is 5. Because that's the only way I'm going to be able to get to 50 for my X and Y intercepts. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 20, 25, 30, 35, 40, 45, 50. All right, so here is the line for the pounds of fish we're getting. And remember, I had to do a scale because otherwise we are not counting each line as the same number. That is extremely important when we're graphing. So finding these x and y intercepts, I can do that because both of these are going to give me whole numbers. So if I had 4x being equal to 240, my x value would be 60. And then if I had 3y being equal to 240, my y value would be 80. So I can graph both of those x and y intercepts without any issue. So I know this was 50. I'm counting by fives, so this would be 55, 60 for perch. Again, this was 50, 55, 60, 65, 70, 75. Ah! Darn. It was close, but didn't have enough. All right, so I'm going to connect these. Maybe. And then I have to be less than my money equation and more than my pound equation. So it's, again, the space in between here. And then if I'm looking for possible solutions, let's just do, I'm going to do this point and this point just because they're close. Now remember we counted by fives. So this would be 5, 10, 15 to get to that x value. So I would have 15 pounds of perch and 5, 10, 15, 20, 25, 30, 35, 40 pounds of salmon. Then for this one, we'd go over 5, 10. So that's 10 pounds of perch and 50 pounds of salmon. Oops, only one L. All right, moving on to number 3. So We Sell CD's website is going to purchase ads to advertise their site. Operating budget will allow them to spend at most $3,000. An ad is $30 in the weekday paper and $50 on the weekend paper, and they plan to run at least 20 ads. So I'm going to say that our weekday is X and our weekend is Y, and that's going to be the number of ads for the weekday and the number of ads for the weekend. So I know that those numbers of ads that they want to run is at least 20. And then I have to do my cost equation. So I'm going to have 30x plus 50y at most 3,000. So 3,000 is the biggest we're going to be able to do. So I only have 15 spaces here, so I'm not going to be able to do 20 for X and Y. So I'm going to, well, let's see. I'm going to do the X and Y intercepts first and see how high I need to be able to get. And then we'll go from there with figuring out what we want our scale to be. So if I have 30x being equal to 3,000, that would give me an x value of 100. And then if I have 50y being equal to 3,000, that gives me a y value of 60. So I need to be able to get up to 100. So I'm going to go ahead and say that my scale is 10. Otherwise, I'm just not going to have enough space. So this is my weekday ads. And this way is our weekend ads. All right. So my weekday intercept is 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 5, 6, 7, 8, 9, 10. Sorry, I just had to double check. And then my weekend is going to be 60. 1, 2, 3, 4, 5, 6 is going to get me to 60. So that represents our money equation. And again, this looks different because we have a different scale. So it's a little bit smaller. And then here, my x and y intercepts, because the coefficient for x and y is 1, then my intercept is going to be 20 for both of those. And I'm going to connect that. Again, we are only dealing with quadrant 1 because this is real life. And in this case, it's going to be shaded in between again. So you can pick any of the coordinate points in there, but remember your scale is 10. So if I did this point right here, that would be 20 weekday and 10 weekend. And then whatever other point you want to pick, as long as you remember you're counting by tens. So let's go ahead and look at the second page here. You know I love number 4 already, because it's talking about knitting. So we're knitting scarves and sweaters. So I'm going to make X the number of scarves and Y the number of sweaters. So she's saying that scarves take 2 hours to knit and sweaters take 10 hours to knit. I'm going to be honest with you, that's not realistic. It takes a lot more than 10 hours to knit a sweater. But anyway, so no more than 40 hours a week knitting. So I'm going to make my hourly equation. So 2 hours for scarves, 10 hours for sweaters, and no more than 40 hours. And when I combine the number of scarves and sweaters, she wants it to be at least 5. Now, I know right off the bat that I have 15 because I already did that. I counted ahead of time. So I'm going to go ahead and find my x and y intercepts here and see if I have enough space. And if not, then we'll go back and think of a scale that we could use. So I would have 2x being equal to 40. So that means my x-intercept is going to be 20. So I don't have enough to count by ones. And then 10y equals 40. So my y value is 4. So if I count by twos, I'll be okay. So this is the number of scarves. And this is the number of sweaters. And remember, we're going to do a scale of 2. And the only reason I'm okay doing a scale of 2 when I have to graph a 5 is because I know that I can graph a half pretty accurately. If you don't want to graph in between 4 and 6 to graph 5, it's totally okay if you make a bigger graph, and that would be absolutely okay. So to get to 20, 2, 4, 6, 8, 10, 2, 4, 6, 8, 20, and then a y-intercept of 4. So this is 1. And then 2, 4, 5, 2, 4, 5. All right, now, pardon me. Now we're getting to the point where we're going to cross over a little bit. So I have to be more than this and less than my time. So now we're in here. Oh boy. So now my number of scarves and sweaters is living in this little box here, or this little triangle space. Now again, if that's too small for you to deal with, it is okay to make a bigger graph. But I'm going to go ahead and show you, even though I counted by twos, I can still be accurate with my halfway points. So this is 2, 4, 6 scarves. And because I'm counting by twos, I know this is 1 sweater. And again, you can pick any other point that you'd like. But I'm going to go ahead and move down to question number 6. Because there's more questions here that we haven't seen examples of before, and I want to make sure that you get that in this video. So we're doing baseball and soccer games. So this is the number of baseball games and the number of soccer games. So I'm going to label baseball X and soccer Y. And again, I'm just being lazy and abbreviating. Obviously, if this was the test, you would fully spell it out and make it beautiful. All right, so let's write some equations. We do not want to spend more than 15 hours traveling, and you want to attend at least 8 games. So I'm going to do my travel and my game equations or inequalities. So let's do the travel one first. 15 is the most number of hours I want to spend in the car. So it's 2 hours to get to a baseball game and 1 hour to get to a soccer game. And I want to attend at least 8 games in total. Now I'm going to be okay counting by ones on this graph. So I'm going to go ahead and do my X and Y intercepts here because they're both going to be 8. And I'm going to go ahead and connect those. And because I want to be over 8, I know that my shading is going to be on this side, just to keep that in your mind. Now this 15 divided by 2 is not going to give me a pretty answer, so I'm going to go ahead and convert this. Y is less than or equal to negative 2x plus 15. So I'm going to graph this in slope-intercept form. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Beautiful. So I'm going to go down 2 and over 1. All right, so here is my travel inequality. And I don't want it to be, froze. I'm gonna wait for it to catch up really quick. There we go. So this part over here is not going to be shaded in because that is over my travel time. So it'll be that little sliver and then in between those. But again, only in quadrant 1 because I can't have negative baseball games or negative soccer games. So that's my shading. Okay. So suppose we decide to attend 4 baseball games. That tells me my X value is 4. 1, 2, 3, 4. Okay. What is the range of soccer games you can attend? So I'm going to look at this space here. That's the number of baseball games I'm going to go to. So my soccer games are going to line up based on that. So that would be 1, 2, 3, 4 soccer games, 2, 5, 6, 7 soccer games. So I could go from 4 to 7 games because that's the space that's shaded in between where X is 4. So now we're going to do the opposite. If I go to 9 soccer games, so this was 8, right? So here's 9 soccer games. So now this space here is what we're looking at. What's the number of baseball games we could attend? Well, we could go from 0 to 1, 2, 3. Because that's this chunk in here that's shaded when I have a Y value of 9. So now they gave me a point, 6 baseball games and 4 soccer games. And that's not possible because it is outside of that shaded area that we worked on creating between the number of games and the hours traveling.